Hi everyone. So let's see this question. It was asked in GATE 2006. So it is a simple integrated based question. So in this video we are going to see why this question is wrong. This question is absolutely wrong. For this particular question, some people gave this answer 8.93 volt. This is certainly wrong, and IITs gave this answer. I don't know in 2006 who would be the committing organization. 14 it was IIT KGP. Yeah, I guess it would be IIT KGP only in 2006. Okay, so yeah, they gave this answer 9.45 volt. That is also wrong. This circuit is itself wrong. The circuit is also wrong. The circuit will not even work. We will prove it why it is wrong and why they give this answer. First, I will prove why IITs gave 9.45 volt. Okay, then what is the issue with this answer? Now, why people are giving this answer? What is the issue with this answer? Why this circuit is wrong and how we can make this circuit correct? What should have been the correct question? That I will tell, and with proper reasoning. So watch the video till the end, you will get to learn a lot of new things, right? So let's start. So first I will give the reason why IITs gave this answer. So what did they thought? So what did they thought? So for t less than 0, for t less than 0, what is the scene? For t less than 0, the scene is that the switch is open. The switch is closed at t equals to 0. So for t less than 0, the switch was open. And now this is the DC voltage. The 10 volt is DC. This is no step. This is DC voltage. So even if this was open circuited, this 10 volt was there. This 10 volt was there because 10 volt is DC. It is not step. 10 volt is DC. And this switch is open. So this is working in open loop configuration only, no? For t less than 0, what is the circuit? For t less than 0, the circuit is, there is a op-amp, there is this output voltage. One of the node is connected to 10 volt, the positive node, the positive terminal is connected to 10 volt, and the negative terminal is connected to a resistance which is connected to ground. This is driving 0 ampere current, so this node is at 0 volt only. So 10 and 0, output will be coming to plus 15. Say yes or no, right? So for t less than 0, your V naught for t less than 0 is plus 15 volt. So output is saturated to plus 15 volt. Now the switch is closed for t greater than 0. For t greater than 0. Input is still there. Input is still there. There is no issue about the input. Input is still there. The switch is closed now and output is at plus 15. Right? Since output is saturated, look, the capacitor, this is the circuit. So output is not going to change instantaneously. Actually, it will change instantaneously, but what IITs thought, that I am telling you. What IITs thought. What question paper setter thought. Okay, just I am telling you why they have gave that answer. Why they have given the answer of 9.45. So what did they thought? That output is saturated. If output is saturated, what does that mean? That virtual short is not valid. Because output is saturated, so virtual short is not valid. If virtual short is not valid, then what will happen? The capacitor will charge instantaneously. The capacitor will charge exponentially because it has become a simple RC circuit. If output is saturated, it has become a simple RC circuit because if there is I current through it, the same I current is flowing here because input of op-amp will not drive any current. This node is fixed to 0. This node is 1 kilo ohm. I know this whatever that I am doing, that is wrong because there are a lot of wrong things about it that I will tell later on. I am just telling what did they thought about it. What did they thought here? So this was 15 volt. This is simple R. This is R. This is C. So what did they thought is that Now this will become a simple RC circuit, so capacitor will charge instantaneously. Not instantaneously, sorry, it will charge exponentially. So initially VC voltage is at 0 volt, and at steady state, where will VC voltage try to go? At steady state, where will VC voltage try to go? The VC will try to go to 15 volt, because at steady state this capacitor will be open circuited. There will be zero current through the capacitor, so there will be zero current through the resistor as well. So this 0 voltage will be coming here, and this node is 15. So at steady state, VC voltage will try to go to 15 volt. So this would be the equation. So what will be your VCT equation? That would be 15 into 1 minus e to the power minus t by tau. What is tau? Tau is RC, that is 1 milli. And they are asking you the VC value at 1 millisecond. So VC value at 1 millisecond, what will be the answer? 15 into 1 minus e to the power 15 into 1 minus e to the power minus 1 milli by 1 milli. So that would be 9.4548 volt or 45 volt. So this is the answer they gave, and now this is absolutely wrong. There they did the mistake. What is the mistake that they did? Tell me. Can you think about it? You only saw the VC waveform. You did not see the Vx waveform. Will this Vx allow this equation? That is the thing, no? I always told you to check the Vx waveform as well. Always check the Vx node as well, Vx potential as well. Like what is happening at Vx potential? If there is something wrong is happening at Vx potential, because of the change in Vx potential, the output can change. So will this Vx allow this thing or not? So that is the thing. So what is the Vx potential? What is Vxt equation? What is the equation of Vxt? So till now there is no issue about this. There is no issue in this point. The output is saturated, virtual short is not valid. If virtual short is not valid, I can write the Vx potential. Initially the capacitor is uncharged, so 15 volt will be coming here, right? 15 volt will be coming here. Capacitor is uncharged, so this 15 volt will be directly coming here at Vx. So what will be your Vx potential at t equals to 0 plus? That will be 15 volt. And at infinity, what will be the Vx potential? It will be 0 volt, right? At infinity, it will be 0 volt. Why it will be 0 volt? Because capacitor will be open circuited, so resistor will drive 0 ampere current. So this 0 will reach here. So at infinity, Vx will be 0 volt. So what will be your Vxt equation? That would simply be 15 into e to the power minus t by tau. Tau is 1 milli. So that would be your Vxt equation. If that is the Vxt equation, what is the Vx value at t equals to 0 plus? That is 15. So let's check in the circuit. What did I say? For t less than 0, the switch was open, so output is saturated to 15 volt. Now the switch is closed. If the switch is closed, then the capacitor cannot charge instantaneously. Certainly the capacitor cannot charge instantaneously. So this 15 volt will be coming here. If this 15 volt is coming here, so V negative node is at 15, V positive node is at 10. What will be the output voltage? At t equals to 0 plus, your V negative is at 15 and your V positive is at 10 volt. What will be the output voltage? Output voltage will remain at plus 15. No, it will go to minus 15. Immediately it will go to minus 15. 15 came, so here it is 15, here it is 10. Immediately it went to minus 15. Right? So V naught voltage at t equals to 0 plus, immediately it went to minus 15 volt. Now tell me one thing. If it immediately went to minus 15 volt, then what happened in the circuit? Output is still saturated. Output is still saturated. Again, the concept of virtual short is not valid because output is saturated. If output is saturated, then what will be the Vx potential now at t equals to 0 plus? What did I say? All this happened at t equals to 0 plus only. 15 volt was there, 15 volt came, it's negative terminal, so there is 15 volt positive terminal side, that there is 10 volt. So 15 and 10, output will be saturated to minus 15. It happened in 0 second because there is no slew rate, ideal op amp is there. 15 came, minus 15. Now what will happen? This minus 15 will again come because the capacitor is not going to change its voltage instantaneously. There is no current, nothing, there is nothing like instantaneous, there is infinite current or nothing like that. So capacitor will hold its voltage, that was 0 volt only. So this minus 15 volt will come. If V negative node is at minus 15 and V positive node is at plus 10, where will this output go? Again at plus 15. All this is happening at t equals to 0 plus only. Everything is happening at t equals to 0 plus. 15 was there, 15 went to V negative, output was minus 15. Minus 15 was there, minus 15 went to V negative, output was plus 15. Again plus 15 will go, output will be minus 15. Plus 15, minus 15, everything is happening at t equals to 0 plus only. Plus 15, minus 15, plus 15, minus 15, it is happening at t at this node only. This like this. The circuit is itself is wrong. It cannot happen. It is not possible. The circuit is not even working. The circuit is not even going ahead. Plus 15, minus 15, plus 15, minus 15, plus 15, minus 15. That is flowing in the loop, and that also at t equals to 0 plus only. Did you understand this point or not? Okay, so this is what I am going to write now. So now V naught is minus 15. Now Vx at 0 plus would become minus 15 volt. So what does that mean? V negative is at minus 15 and your V positive is at 10 volt. What does that mean? That your V naught positive will be plus 15 volt. So your V naught is toggling between plus 15 and minus 15 only at t equals to 0 plus. The circuit will not work. The circuit will not work. This is the final conclusion. Okay, I have thought about it enough. I have talked to a lot of people about this question. There is certainly the circuit is wrong. Now, a lot of people gave this answer. Why did they give this answer? I will tell you the reason, and where they are wrong, that also I will tell you. So they gave this answer. What did they thought? This was the circuit we had. They did not analyze the circuit from t less than 0. What did they say? They analyzed the circuit from t greater than 0, because mostly for gate aspirant or even for the educators, they have the habit of analyzing the circuit from t greater than 0. But it's not the case. Always analyze the circuit from t equals to minus infinity. Always start what is happening before the switch is closed. After that come to the switch is closed. So always start from here. I have told this thing hundreds of times when I was teaching network analysis, when I was teaching analog electronics. Always start your circuit from t equals to minus infinity, not from t equals to 0. So what did they do? They did not think that output will be saturated. Okay, they just said that the switch will be closed at t equals to 0 plus. The switch will be closed, and if switch is closed, the virtual concept is valid. The concept of virtual short is valid. This is what they thought. The concept of virtual short will be valid, and now I can apply the equations and I get my V naught value. But the concept of virtual short is not valid here. Output is already saturated. The concept of virtual short is not valid. And even if you say that, let's just say they are saying that, okay, I am considering that output is saturated, output is at plus 15 volt. I am considering the fact that output is saturated. Still, I am saying that concept of virtual short will be valid. Okay, let's just say I am agreeing that concept of virtual short is valid. I am agreeing to the point that, sir, you are saying that concept of virtual short is valid, so I am agreeing to this point. If I am agreeing to this point, then what will happen? This will be 10 by R current. This will be 10 voltage, right? Concept of virtual short is valid, so this will be 10 voltage. What will be this current? This current will be 10 milliampere, right? This current will be flowing through the capacitor as well. 10 milliampere current is flowing. So through the capacitor, finite current is flowing. Now tell me one thing, what was your VC potential for t less than 0? For t less than 0. VC 0 minus. It was 0 volt only. Do you agree to this point? Because switch was open, there was no current through the capacitor, so VC was not holding any voltage. It was 0. What is your VC 0 plus? Here you are saying it is 15 volt because output is saturated. That you are agreeing. There is no doubt about it. Output is certainly saturated. That you have to agree. Now I am agreeing to your point that You are saying that even if the output is saturated, I will still apply the concept of virtual short. I said, okay, you can still apply the concept of virtual short, but let's talk about the VC potential. For t less than 0, you are saying it is 0 volt. Just for t greater than 0, you are saying this node is a 10 and this node is a 15. So what will be your VC potential? 5 volt. You are saying that there is finite current flowing through the capacitor, that is 10 milliampere. And even if there is finite current flowing through the capacitor, your voltage is changing from 0 to 5 volt. Is that possible? No. Did you understand this point? Your VC 0 minus was 0 volt. Now you are saying that I know output is saturated. You have to agree to this point because switch was open, output was saturated. Even if the output is saturated, I still want to apply the concept of virtual short. I said, okay, apply the concept of virtual short. What was your VC 0 minus? 0 volt. What will be your VC 0 plus if you apply the concept of virtual short? That will be 5 volt. What is the current flowing through the capacitor? 10 milliampere. That is constant. So there is constant current flowing through the capacitor, 10 milliampere. And still you are saying that capacitor is changing its voltage instantaneously from 0 to 5 volt. Is that possible? No. So concept of virtual short is not valid here. Output is saturated, still the concept of virtual short is not valid. You thought that you can apply the concept of virtual short because output is, even if the output is saturated, then what happens? We can still apply the concept of virtual short. But if you apply the concept of virtual short, the capacitor is changing its voltage instantaneously, even though there is a finite current flowing through it. If there is a finite current flowing through it, the capacitor voltage will charge linearly only. So it is absolutely wrong to apply the concept of virtual short here. Then how they could have made this question correct? What would have been a correct question? So let's check that out. What would be the correct question? Correct question. They only had to do one change. What was that change? That change would have been just to make this 10 volt as 10 UT. If they had made this as 10 UT, let's forget about it. And what they could have written? They could have written that the switch is closed at t equals to 0 plus find t equals to 0 only they can write, not 0 plus. Find VC potential at t equals to 1 millisecond. That's it. Now the input is 10 UT. The input is 10 UT. The input is tapped. For t less than 0, there is no input in the circuit. For t less than 0, there is no input in the circuit. This node is also at 0. So V0 will also be not saturated. There will be nothing at V0. Because this node is also at 0, this node is also at 0. So output will remain at 0 only. Are you getting this point? So for t less than 0, nothing will be happening in the circuit. So the output will not be saturated. If it was a DC potential, if it was a DC potential, this is a step now. That is the best possible thing they could have done to make this question correct. So this is a step now. If this was DC, then output would have been saturated. Output would have been saturated to 15 volt. But now output is not saturated. So you can apply the concept of virtual short. So what will happen at t equals to 0 plus? This is the question. This is the answer. At t equals to 0 plus. I guess I will need to add one more page. At t equals to 0 plus, output is not saturated. Output is not saturated. Plus negative feedback is present. Negative feedback is present. Why negative feedback is present? Because this switch is closed. If the switch is closed, that means negative feedback is there. Plus negative feedback is present. What does that mean? That virtual short valid. So if virtual short is valid, then how would the circuit look like? Virtual short will be valid. This is your VCT. And output is not saturated this time. What will be your V naught T? Virtual short is valid, so this Vx node will go here. Sorry, this 10 volt will go here. So what will be your V naught T? Now this is 10 volts, so this will drive 10 milliampere current. This will drive 10 milliampere current, so this will also drive 10 milliampere current. Right? So what will be your V naught T? V naught T would be 10 volt plus 1 by C, 1 by C, that would be 1 microfarad. And there is a constant current, that would be 10 milliampere only, into time t. That would be your V naught. Did you understand this point? If you don't understand this point, let's write the VCT equation. What will be VCT equation? VCT would be 1 by C integration I dot dt. So 1 by 1 microfarad. From 0 to t we are starting because our circuit is running after, oh, this is step here. This question is changed. Yeah. So our circuit is running after t greater than 0 only. So I can write 1 by C I dot dt. What is I? I is 10 milliampere into dt. So what would be the answer? It would be 10 t into 10 to the power 3. That would be your VCT. And what would be your V naught T? V naught T will simply be 10 plus VCT. 10 plus VCT. Or you can write 10 plus 10 to the power 40 volt. Right? This will be your V naught T. So take care of the V naught potential. Take special care of V naught potential, because output is going to be saturated. Anytime output can be saturated. Let's draw the V naught T waveform. So that will start from 10 volt only. It will start from 10 volt and it is going down. At 5 millisecond, what will happen? Output will be saturated, because saturation voltage is 15 volt, not 5 volt. So is it 15 volt or 5 volt? I'm really sorry for this mistake. Saturation voltage is 15 volt. I'm really sorry for this mistake. Saturation voltage is 15 volt. This is 15 volt. Yeah, saturation voltage is 15 volt. So V naught potential at 0.5 millisecond, what that would be? That would be 15 volt. So it started from 10 volt, it got saturated at 15 volt at 0.5 millisecond. Now output is saturated. If output is saturated, so at t equals to 0.5 millisecond, output is saturated. So if output is saturated, that means concept of virtual short is not valid. Virtual short not valid. Concept of virtual short is not valid, then what will happen? If concept of virtual short is not valid, then it will behave simple as RC circuit only, because concept of virtual short is not valid. So this node is not at 10 volt now. Vx node, this node will not be at 10 volt because output is saturated. If output is saturated, this node will not be at 10 volt. So this will become a simple RC circuit now. Because whatever the current that is flowing through the R, the same current is flowing through the capacitor. And your output is saturated to 15 volt. This is your 15 volt. Where the capacitor would have been charged? Your capacitor would have been charged to 5 volt. This would have been charged to 5 volt. And this is your resistor R, which is 1 kilo. This is your Vx node, right? And this is your VCT. VCT. So tell me, where will the VCT go? Where will VCT go? So VC at 0.5 millisecond plus. VC at 0.5 millisecond plus is 5 volt. VC at infinity, that would be, this capacitor will be open circuited. This capacitor will be open circuited. So VC at t equals to infinity will be 15 volt. Right, at infinity the capacitor will be open circuited. What about Vx? Before that, let's write down the equation of VCT. VCT equation would be 15 minus 10 into e to the power minus t. It is starting from 0.5 milli by tau. Tau is 1 milli. So this is the VCT equation. And what about Vxt? Vx initially it is at 0 volt. No, sorry, it is not at 0 volt. Vx initially is at 10 volt. But eventually Vx will be at 0 volt because capacitor will be open circuited. So this 0 volt will be coming here. So it will be at 0 volt. So this is the equation of Vxt. So Vxt is trying to go from 10 to 0 volt. Right. So this is the node Vx. It is trying to go from 10 to 0 volt. Now Vx node, if it moves to 9 volt, is there an issue at the output? Where is the output? Output is saturated to plus 15 volt. After that, this node is going down. It is not going down from 10 to 0 volt. If it goes to 9 volt, is there any issue at the output? No, because your V positive is at 10 volt and your V negative node is going down. That is at 9 volt. So here 10, here 9. Output will still be at 15. If it goes to 8, there is no issue. If it goes to 7, there is no issue. If it goes to 5 volt, there is no issue. The V negative node is going down. Output will always be at 15 volt. So it will certainly behave as a simple RC circuit with this node being 15 volt and this node being ground and this node being 15 volt. So it is behaving as simple RC circuit. So whatever the Vx equation that we wrote, that is correct. But here in the previous case, the Vx equation that we wrote, that is wrong. This equation is wrong. Why is that wrong? Because at the very next moment output is having the problem. Output is saying that from 15 I will immediately go to minus 15. So your Vx equation should change. This Vx equation should change. Output is saying that I'm immediately going from 15 to minus 15. So Vx equation will change now. Then it is saying that it will go to 15, then again it will change, again it will change, again it will change. So the circuit itself is wrong, circuit will not work. But here the Vx potential is going down. It will certainly go down. It will go down slowly. So there is no issue about that. It will go down, not slowly. I shouldn't say it will go down slowly. I should say it will go down exponentially. Right? So this is the VCT equation. We just need to find the VCT value at 1 millisecond. What is the VCT value at 1 millisecond? 15 minus 10 into e to the power 1 milli. So it would be 0.5 milli divided by 1 milli. So e to the power minus 0.5. It will come 8.95, whatever that option I wrote. The power into 10 minus 15, 8.93 volt. 8.93 volts. So this is the VC value at 1 millisecond. So this would be correct only if there was a step input instead of the DC input. So they could have framed the question correct if they did not do this mistake. So here I am going to draw the Vx waveform. This is your Vxt waveform. So for Vxt waveform, initially it was at 0 volt only. Then after 5 milliseconds, the concept of virtual short node was not valid. So Vx node will rise. And Vx node was at 10 volt. Vx node was at 10 volt. It was at 10 volt. After that, after this, what happens? The Vx node start going down. The target of Vx node is to go from 10 to 0 volt. So it will start going down. and it will certainly go to 0 volt at steady state, right? This is how it will go, and this time was 5 milliseconds. So this is the equation of Vx. What about the equation of V naught? What about V naught? So V naught started from 10 volt initially because the concept of virtual short was valid. Then it went down. So color I can change. Then it went down till 15 volt, and then it remained saturated there. It remained saturated to 15 volt only, right? What was this time? This time was 5 millisecond. Not 5 millisecond, yeah, 0.5 millisecond. This time was 0.5 millisecond. This was minus. Wait a second. Why did I draw this waveform? From 10 to it is going to 15, no? 10 to 15. So it is increasing only. I'm really sorry for this. From 10 to 15 it is going. Ten volt to 15 volt. Yeah, so 10 to it goes to 15 and then it stays there. And the last thing, your VC waveform. This would be your VC waveform. So it started from 0, then it charged till 5 volt. Started from 0, it charged till 5 volt, and then it rose exponentially. It will certainly go to 15 volt. This time was 0.5 milli, and it charged to 5 volt. At steady state it will go to 15 volt, right? 15 volt only, no? Yeah. At steady state this will be open circuit, so this will be this will be 0 and this will be 15 volt only, so it will go to 15 volt. So this would be the correct waveform. These are the correct waveform, but not for the given question, for this particular problem. So this is the correct question which should have been marked. This is the correct question where your input is tap input, but here they gave the DC input, so it made the whole question wrong, because here you are having 15 volt, that 15 volt is coming flowing in the loop, and those who gave the answer as like those who applied the concept of virtual short here, they can see that if I apply the concept of virtual short for a DC input, then what is happening? Initially the voltage was 0 and suddenly the voltage is becoming 5 volt. In this case, suddenly the voltage is not coming 5 volt. In this case, there is a linear current that is charging the capacitor. Output is not saturated. So I cannot say that 15 minus 10, your VC potential will be 5 volt. No, no, no. 10 volt is there, the 10 milliampere current is there, that is linearly charging the capacitor. So your VC is linearly charging to 5 volt and then exponential charging. Both are possible, right? But immediate charging is possible only if there is impulse current that is not flowing there. So yeah, this is how the circuit would look like. This is the complete analysis. So I hope you must have understood a lot of things here. So if you found it helpful, please do like this video. Okay then, thank you.